Traumatic brain injury, or TBI, can cause significant damage to the brain tissue as a result of the primary impact or from secondary mechanisms such as inflammation, oxidative stress, neuronal damage, and fluid accumulation or edema. Perilesional edema, characterized by an increase in proinflammatory factors and immune cells, is a common cause of secondary damage. While the nucleotide-binding domain and leucine-rich repeat family pyrin domain containing 3-protein, or NLRP3, is a key factor in secondary damage, its exact role has been scarcely explored. Furthermore, pioglitazone, an anti-inflammatory drug, has been shown to reduce the levels of NLRP3 and other inflammatory cytokines. Precise mechanisms underlying this effect remain unknown, however. Researchers from Catholic University of South Korea thus sought to investigate the role of NLRP3 in secondary brain injuries and whether it can be pharmacologically modulated using pioglitazone. For this, they used 3 groups of mice, namely control C57 BL6, NLRP3 knockout, and pioglitazone-treated mice. They induced head injuries in the animals using a weight drop model. Next, they measured brain water content, indicative of edema, and changes in the level of inflammatory cytokines and NLRP3 inflammasomes. The researchers noted that brain edema was the highest in the control group animals on day 3 after TBI and significantly lower in the NLRP3 knockout and pioglitazone-treated animals. Further, pioglitazone treatment significantly decreased the levels of interleukin-1 beta, capsase-1, and NLRP3 and reduced inflammasome activity. Treatment was also associated with a decrease in the activation of astrocytes and microglial cells. Overall, these findings suggest that pioglitazone reduces NLRP3 inflammasome-mediated edema and inflammation following TBI, and may therefore be a useful neuroprotective strategy in preventing secondary brain damage.